So we'll start then. So I've already made the VPCs, assign interfaces to it, and we're gonna do the configuration of VPC. So for the VPC, I'll go and give IP address to this interface. Let that be 10.1.1.0/24, and I'll keep this in a different VRF. So I'll first make the VRF, assign the interface to the VRF, and give it a IP address. So VRF context, we'll create a VRF, assign the interface 3/26 to the VRF, and assign it with the IP address. We'll ping to verify. We'll move forward to my feature of VPC and LACP. Which we'll do on both the sides, and then we'll configure my VPC domain. Let this be 700. Here, keep alive destination 10.1.1.2. Source is VRF is so here also VPC domain 700. Here keep alive destination would be 10.1.1.1. Source 10.1.1.2. VRF PKAL. Show VPC should show you the peer is alive. Next is my peer link. So interface Ethernet 3/6 and 3/16 is channel group number 700. Mode is active. Interface port channel 700 is my switch port. It's a trunk port, and it's a VPC peer link. Here also on interface Ethernet 3/7 and 3/21. Channel group number 700. Mode active. Interface port channel 700. Switch port mode is trunk. VPC peer link. So we'll make them up, check if the peer link comes up. Show port channel summary. So show VPC should show you peer adjacency has been formed. Now next is member ports. So we have two member ports to be configured here, VPC1 and VPC2. So on VDC1, we'll go to interface Ethernet 5/3. Give the command of channel group number 1. Mode is active. Interface port channel number 1 is a switch port. Switch port mode is trunk. And VPC number 1. I'll do the same on VDC2. Interface Ethernet 5/9 is a part of channel group number 1. Mode active. Shut it down. Interface port channel number 1 is a trunk port, and it's a VPC number 1. I'll first do it in VDC3, feature of LACP. Interface Ethernet 5/4 and 5/10 is a part of a channel group. where that channel group is also a switch port. Switch port mode is strong, and interface Ethernet 5/4 and Ethernet 5/10 no shut. I know this is VPC primary, that's why I made him no shut first. Show VPC should show you the port channel 1 is up. I'll do the same on 5/9 no shut. So VPC here also should show you it has come up, and we'll do for the another VPC, which is my 5/41 interface going towards switch 1. So interface 5/41 is under a port channel number 2 mode active. Interface port channel number 2 is a switch port. Switch port mode is strong, and VPC number 2. Here also interface Ethernet 5/42 is a part of a channel group, and that port channel is a trunk port and VPC member port number 2. I'll go to switch 1 here. I'll go to my interface. All of the interface I don't want it, so I'll shut them down. Only that I want is 21 and 22. Is where I'll go and give what command? Channel group number say 2, mode is passive, no shut. Interface port channel number 2 is a switch port. Switch port mode is trunk. Switch port trunk encapsulation .1Q. Switch port mode is trunk. No VPC configuration here on switch 1, right? Now what about this port going here? So let us make the VPC up first. Interface Ethernet 5/41 no shut. Show port channel summary. This should be up, and it is. Show VPC should show you both are up for the primary side and on the secondary side as well. If I turn the interface up, the port channel number 2 also should come in P state, and show VPC should show you both are up, right? Now this port that goes to VDC4 is considered, this VDC4 is considered as right now a orphan device, right? And this port connecting them is just a normal trunk port. So I'll go to VDC2, I'll go to that interface, which is my Ethernet 5/11. It's just a normal trunk port. So I'll give the command switch port mode is trunk, no shut. And the interface that connects in VDC4, that also is a normal trunk port. So switch port mode is trunk, no shut. What I'll do is I'll create more SVIs as well on the all of this device, so that we verify by pinging them. So I'll make a SVI for VLAN 10. Let us use VLAN 10 here. So let us say I have a 10.1.1.3/24 IP here. So let that be 11 for him. For VDC1, let that be 1. For VDC2, let that be 2. And for VDC4, let that be 4. These are my SVIs for which VLAN 10. Okay. So let us create this SVIs. So for creating SVI, what do we need to give? Feature interface VLAN. And create the SVI. So first create VLAN 10 and then create the interface VLAN 10, give it an IP address. So for VDC2, for VDC3, dot 3, dot 4 for VDC4. Switch 1, it's 11. This is not required, right? So it's better that this switch also runs rapid, right? So that the convergence becomes faster. So let us check show spanning tree for VLAN 10. What does it say? It's telling my port channel number 2 is a root port and in a forwarding state. Okay. So IP interface brief should show you that VLAN 10 interface has come up. And because of this coming up, I should be able to ping everywhere right now, right? So I should be able to ping from one VPC to another VPC, which is VDC3 to switch 1. So I should be able to ping from VDC3 to switch 1, which what's the IP address? 11.
Yes.
Right, and what is the IP address of VDC1? Dot 1.
Yes.
I can ping dot 2. I can ping dot 4, which is the orphan device, right? All of them are pingable right now. So everything seems fine when the VPC is fine, right? Now we'll see into failure scenarios and copy this chart first. So we'll see the failure scenarios and we'll see 4 cases of it, where the first case is peer link is up, peer keep alive down, peer link down, peer keep alive up, first peer keep alive goes down, then peer link goes down, or first peer link goes down, then peer keep alive goes down. What will happen? What will be effect on election? What will be effect on VPC? What will be effect on SVI? What will be effect on the data traffic? What is effect on orphan devices? How to recover it? Okay. So this will cover your entire failure scenarios. So in our diagram, who's the primary VPC device right now? VDC 1, and who's the secondary? VDC 2, right? So the primary is this guy right now, and this guy currently is the secondary. So the first case, number 1, peer link is up. What is down? Peer keep alive is down. So what will happen? Let us check that out. Okay. So the peer link is up. This one. What when goes down? This link. Peer keep alive goes down, right? In order to simulate that, I'll go to my VDC1 and shut down the 3/20 interface. So if I shut it down and check show VPC, that should show you that my peer is alive, it's showing you, but now showing peer is not reachable through peer keep alive, right? But did the peer link go down? No. Adjacency is still up. Consistency checks all are passed. I still retain the role of primary, right? He still retains the role of secondary. The peer link is up, VPCs are up on the primary, VPCs will also be up on the secondary. There is no effect at all when just the peer keep alive goes down, right? So when the peer keep alive goes down, was there any effect on the election? No, right? Primary remain primary, secondary remain secondary. Was there any effect on VPC? VPC still remain up. Was there any effect on SVIs? Let us check. Show IP interface brief. SVIs are up, right? On primary also, on secondary also, both SVIs are up, right? Was there any effect on data traffic? No, that is also not affected. Orphan device, everything is up. Recovery, yes, you have to do recovery. Why? Because there may be a case that peer link goes down after that. After that, if peer link goes down, then you are in a trouble. You'll be in a trouble of split brain scenario. So we have to recover, but this recovery is more related with peer keep alive link. So it will be more related with troubleshooting of IP reachability, layer 3 reachability, right? So troubleshoot here in this case, what? Layer 3 reachability. For my peer keep alive link. So nothing adverse happens when your peer keep alive link goes down, but it's a very important component because it's to detect whether the peer link has gone down, right? So if peer keep alive does not exist and then peer link goes down, then we are in a problem of split brain scenario. But just the peer keep alive going down, nothing happens. So in order to recover it, I just need to go and no shut the interface that I have shut down. So which is my 3/20 interface. So when I now do show VPC, that should show me everything is fine again, right? Nothing happened when it came up also. Now the scenario is your peer link is down, peer keep alive is still up. So when my peer keep alive went down, nothing happened. Now let us check if peer link goes down, what happens? Which is my peer link? Port channel 700 is my peer link, right? I'll shut it down. If my peer link is going down, what is happening here is your synchronization is not happening. If your synchronization does not happen, there are two brains, right? Then two brains forwarding the same packet. Can two brains forward the same packet? The brain has to be synchronized to forward the same packet, even if there are two brains, right? That was synchronized with the help of what? The peer link. But the two brains are trying to forward the same packet if it goes down. So I need to make sure that only one brain is active at a time then, right? How would I make sure of that? Make the secondary go down then. So what happens when your peer link goes down? Nothing happens on the primary side. So if you check show VPC here on the primary side, you will see primary retains the role of primary, right? Everything is fine except for the peer link has gone down and your peer link is down, but your VPC is not affected. It's still up on my primary side. But if you check on the secondary side, you'll see the peer is down. That's why it has made its member ports down. Okay? Because we are not having two brains, we have to make sure only one brain is active at a time. So what he does, the secondary will make sure that the member ports of it goes down. Not only the member ports, SVI as well. Okay, what about the primary side? Primary side SVI is still up. Secondary side member ports went down, SVI went down. Okay. Now there is a problem when if they say this SVI was treated by this orphan device as its gateway. What happens then? If this went down, what went down? This also went down, and his default gateway, if that was configured as this, goes down. Right? That's bad actually. So the recommendation is, in case you have orphan device, connect it to whom? Primary. Because primary, you see the SVI still remains up, right? So it's good to always connect to the primary. That's why it's good to hard code the role first. You exactly know which is primary, you exactly know which is secondary, and then you put, in case you have two orphan devices, which is not recommended for a VPC design, right? But there may be cases where you have to put it because the management says it, right? So then you need to put that, but put it in the primary side. Okay. So as you see here, what happens when your effect, was there effect on election? There was no effect on election though. Primary still remain primary, secondary still remain secondary. Why? Because the peer keep alive was still up to tell that primary is still alive. So secondary will not change its role. But for my primary side, the VPC remained up. For my secondary side, the VPC went down. Right? What about the SVI? The same thing happened. What about the data traffic? Data traffic will still flow. It may affect the orphan device if it has to go to outside network. If it's a default gateway going through my secondary VPC device, it may affect that communication, but the layer 2 communication is not affected. And the orphan port, what happened to the orphan port? Which port is the orphan port here? 5/11, right? Let us check what happened to that. So 5/11 is still up, nothing happened, right? Whereas 5/42, which is a member port of VPC, is suspended by VPC, as you see, right? What happened to these ports? They were suspended by VPC. So nothing happens to your orphan port also, it's still up. So you need to recover it.
The orphan never has to, by VPC keep alive chain. It should not always take the peer link, but it has to take the down path.
It will take the peer link, this correct. Orphan device can take the peer link, no problem. Okay.
Only when it's down.
Not when it's down. When it's up also, it can take the peer link, because VPC check does not happen for orphan ports. VPC check only happens for your VPC member ports. So if it comes, it will pass through. Now, for the recovery, we have to recover the peer keep alive link, and this is normally a problem that might be related with your port channel going down, or your port channel not having the compatibility parameters that's needed for the port channel to come up, right? So we will troubleshoot the peer link in that case, and it may be any problem there actually. But there are some commands that helps us not to make this happen. If I don't want the secondary side SVI to go down, there is a command with which help I can make sure that secondary side SVI does not go down. I cannot help when it comes to VPC member ports. Member ports will go down, but I can save the SVI from not going down. Okay, the command to do that is you have to go to the VPC domain, which is my 700, and you have a command called dual active exclude interface VLAN and the VLAN number.
You need to go to domain.
So what it's telling, dual active exclude interface VLAN 10, do not suspend interface VLAN 10 if the peer link goes down. from the secondary VPC side. If I give this command right now, it has no effect. Why? Because this command triggers when the peer link goes down. It's already down, right? So what I'll do is I'll make it up again and make it down again. So interface port channel number 700, I'll do no shut. The VPC should come up again, the peer link. Right, peer adjacency has been formed and everything should come up fine. On the secondary side also, it should come up back again, which does take some time. As you know, after the peer link comes up, how much time does it take? So that time also can be decreased. If you go to VPC domain, you have a command called delay. So delay, restore. And what do you want to restore? After how much amount of time do you want to restore your VPC member ports after the peer link comes up? Or after how much amount of time do you want to restore your interface VLAN after the peer link comes up? This is time after the peer link comes up. Peer link has to come up. Okay. So if I can change this timer to make it fast, but not recommended, do that the same value. Okay. So I'll just give this time. Let us check again. Show VPC. It should come up now. Everything is fine, right? Previously you saw the SVI going down. Now what command do I have? Under my VPC domain, I have this command. Delay restore, not sorry, this one. Dual active exclude interface VLAN 10. What it's telling? Exclude the interface VLAN 10 from going down.
Should be on both.
It's only affecting secondary, right? So when the peer link goes down, it only affects secondary side. The SVI of primary still remains up. So this command has no effect on primary. This command only affects the secondary. So if I go to port channel number 700, shut it down. What should happen now? Peer link goes down. So if you do show VPC, peer link is down. Nothing happens to primary. His member ports are still up. Show VPC here. It's secondary, so his peer link, this port channel of member ports goes down, right? But what should not have happened is his SVI should still be up, and it is up. Okay, because we excluded it from going down. But as you see, the orphan device didn't go down, right? Orphan port, did it go down? It didn't go down, right? There may be cases where I want the orphan ports to go down, where I want my orphan ports to go down. In what case it may be?
But in that case as well, or in that case, orphan port is still up, but it is not able to communicate with the secondary because it is still on.
Which one? Yes, orphan port is loose with communication. As you would see that if the secondary is suspending his member ports, this is down, right? And peer link is also down. Yeah. Now this is a layer 3 link. So orphan device obviously will lose its connectivity.
Right. It will not have any use.
Yes. Yeah. But if like in case it was dually attached, but not in VPC. Okay. It was just dually attached. There are cases where servers are dually attached, right? But not in VPC way. It's an active standby way. Okay. Servers are dually attached in a what type of way? Active standby way. It's not a VPC say. Okay. And if this was my orphan port because he was doing VPC to other devices. This is a orphan device only. It's dually attached. That doesn't mean we are doing VPC. Right? We are not doing VPC. This server is connected as an orphan device only. Okay. And if this was my say primary and this was the secondary VPC, and what he was doing is this port was active and this port was standby. Suppose for example, 10. Right? Now this server relies on what? to fail over this link, right? If this link fails, then this standby link becomes active for the server. And all depends upon the failure of this link, right? Now, as you see, if the VPC went down and the secondary is not doing what? Not doing, making the orphan device go down, orphan port go down, then the server cannot do a failover because it's still up. He still thinks this path is active. So there may be a case where I like the orphan port to go down, right? And there is a command for that as well. If you want the orphan ports to go down, because as you see, it doesn't go down by default. So if you go and under the interface, you have that command. So interface Ethernet 5/11. If you want this to go down, you have a command VPC. But VPC command, which command? Orphan port, suspend. But when VPC secondary peer link goes down, this is also applicable only to secondary again.
Previously, you use the command do active exclusion.
That is for SVI.
SVI.
This is for my orphan port. Okay. So what's telling? When the peer link goes down on the secondary side will make its orphan port also go down.
But SVI is up.
SVI will be up. But by default, SVI goes down. Because of that command, SVI is up. Now to trigger this also, what do I need? To trigger this, I need to, again, because this only triggers when what happens? Peer link goes down, it's already down. It doesn't trigger it. Okay. So if you do show interface brief, 5/11 is still up, right? So in order to trigger this, I need to make my port channel 700 again up. Check the VPC comes up. Check the secondary side is fine. And secondary side is fine. Now make it down. So you need to know how to verify and how to simulate things actually. Okay. So interface, what will I make it down again? The port channel 700. Shut it down. Now what do you have here? Show. What do I check? Show VPC on the secondary, it's down. Show IP interface brief. This is telling down, right? Right now. It's down because not of this reason actually. It's down because of this reason. There is no ports that carries VLAN 10, right? If there are no ports that carries VLAN 10, will the SVI come up? No. So I have to have a port that carries a VLAN 10, right? Then only it will come up. But what happened if you check show interface brief? 5/11 also went down now because of that command that we gave to make the orphan port also go down. But remember, this two are applicable only in secondary VPC side because only secondary makes it down, not the primary. Primary is still up. That's why the role is very important to understand. It depends upon the roles itself how failure occurs in VPC. Okay, always I told who is punished always is secondary. So I'll remove that again. I'll make them up again. So if they are up, everything should be fine, right? So in the second failure scenario, I see some exceptions. I can make SVI not go down for secondary. I can make the orphan device go down for secondary. Those were the exceptions, right? So let us again verify if everything is fine, working fine again. Show VPC. It's up in primary side. Should be up in the secondary side as well. Now a third case is like the first case. But a little bit different is first the peer keep alive went down. After some time, peer link went down. Okay. So first what went down? Peer keep alive went down. Then after some time only, your peer link went down. So first peer keep alive went down. So let us make that down. So I'll go to one of the VDC interface Ethernet 3/20, shut it down. What happens? Nothing happens, right? But why should you restore is after this, if the peer link goes down, then you are in a problem. Why? Because now I don't know whether the primary is there or not, right? Secondary has no idea of the existence of primary because the existence of primary were detected either via peer link or peer keep alive link. Now both are down. So secondary doesn't know who is the primary. Then what happens to the secondary then? Secondary will become operational primary. What happens to primary? Primary becomes primary because the device didn't go down, right? Only the link went down. So right now I shut it down, nothing happens. But if I then go and make my peer link also go down after some time, then we will have the problem of split brain. So if you do show VPC right now, he is primary, peer link and both are down. Nothing happened to your member ports. If you do show VPC here, he became what? Operational primary. Nothing happened to his member ports also. Why is primary? Right? But there is a problem of what? Split brain, because we cannot synchronize our control plane now with the help of peer link. So if there is like two brains forwarding the same packet now, this is bad condition. It's very hard to troubleshoot anything that goes wrong here because the forwarding is unpredictable here. You can troubleshoot only if you know the traffic flow first of all, right? You cannot troubleshoot without knowing what's the traffic flow. So here the traffic flow is unpredictable. You cannot predict the traffic flow. So in case my peer keep alive goes down and then the peer link goes down, the primary remains what? Primary, but the secondary became operational primary, right? What happened to VPC? They were up because both are primary. What happened to SVI? They will also be up because both are primary. Any effect on the data traffic? It's unpredictable. The forwarding is totally unpredictable. Orphan ports are still up, and my recovery here is in cases of split brain, you'll try to solve it by actually shutting down one of the device. Or if you can, troubleshoot the peer link and peer keep alive link first, because in case any one of them comes up, actually peer keep alive comes up, then the problem of primary secondary role will be resolved through the peer link only, right? If the keep alive comes up, can I resolve the roles again? Peer link also has to come up. So you should troubleshoot both peer keep alive as well as peer link, and if you are fast enough to troubleshoot that, you don't have to shut down the device. But in case it takes time, then you have to shut down one of the device, shut down one of the brain. Are you getting my point? So to recover it, you have to obviously troubleshoot first. Try to troubleshoot the peer link and the peer keep alive. And if that's not possible and it's taking time,
If my peer keep link comes up
uh,
in that case, then the situation of split brain will be
still be there because peer keep alive coming up will not resolve your roles, right?
it is the heartbeat of that.
It's just a heartbeat and sending UDP message. It's not telling that your yes, this is not telling it's primary or secondary.
So this primary secondary to primary, should I change manual or it's going to be automatic?
Which one?
Once everything is up,
Uh-huh.
the status for primary and secondary, it's gonna.
Primary is primary, secondary becomes operational primary. Secondary is a operational primary.
Then when the exam up and everything is okay, it's going to be automatic.
So if it's operational primary, and as you know, the VPC role is non-preemptive, so then if the other side comes up, he becomes secondary. Okay, because what matters is the operational role, not the configured role.
So peer link is the brain and
Yes.
is the heartbeat.
Yes. So this actually has very bad types of failures. You can see here with this type of scenario. So what may happen is you have my VPC devices. This was primary, say this was secondary. I have my peer keep alive and peer link configured. These are going down doing VPC to one of the devices. Like this. Right? Now failures can actually occur in this way. The whole device fail, whole primary device fail. Then it's good actually, right? If the whole primary fails, it's good that the secondary becomes what? Operational primary. Because then I know only one device is doing the forwarding of the packets. But if only the link fails, right? Then primary remains primary, secondary becomes operational primary. That's a split brain scenario, and that's bad, right? So in such case, you try to troubleshoot this one, obviously. If that's not possible at all, make one of the devices go down. Okay, but there are other failure scenarios also coming into play, which is that last one. Okay, the last one is telling what?
Peer link goes down.
Peer link goes down, and then peer people goes down. This is the baddest failure that can happen. Now I have my peer link, right? It went down. What happens? When the peer link goes down first, what happens? Primary remains primary, secondary remains secondary. What will secondary do? All member ports shut down. Right? After shutting down the member ports, secondary does not actively check the primary status. Okay? The secondary does not actively check the primary status. Then, after that, this happens. The peer keep alive also goes down. What happens is the peer keep alive goes down, secondary has already turned off this one. Member ports, right? And the peer keep alive only goes down, that's fine. Because the primary is still there to do forwarding. But in case the primary goes down as a whole, then you have a problem. Why? Because the secondary does not become primary anymore this time. Secondary does not become primary anymore this time. He will remain secondary, or everything is down. Every communication is gone. Okay? And there may be cases where in a data center, normally VPC always we think of how many devices? 2 devices, always, right? VPC means to our mind only 2 devices has to be there, right? Now there may be scenarios where you have in your data center everything was working fine and VPC were all working fine. Here people like peer link all were working fine. This was primary, this was secondary. There may be a power outage in your data center. Okay? Because of the power outage in the data center, both the devices went down. Now I had enough power to only make one of the devices come up. Suppose I have enough power to only make one of the devices come up. I made the device come up. Will the VPC come up? I made the device come up, one of the device. Will the VPC come up? For the VPC to come up, what does it do? It will first check here keep alive is up, then it checks here link is up, then it checks consistency parameters has matched, resolves the rows, and then only member port comes up. It has to go through those steps. Without those steps, it cannot just make up VPC. Means even if I have enough power to only power one device and still so that the data traffic still flows, my company is not affected, outage is not there, right? That is my main concern. But VPC will never come up, right? Because VPC needs two devices. The PL link has to come up, PLT collect before that has to come up, and then only your member ports are then turned on. So what you had in the previous version of Nexus OS, I guess it's 5.1 and lower versions, you had something known as reload restore. What did you have? This reload restore command. So in case you reloaded the device and after reloading the device, only one of the device came up, it waits for some time. Okay, approximately 300 seconds is what it waits for, and nobody talks to it with respect to VPC, then it will just bypass all the checks and make the VPC member port come up. For one device. So there was something known as reload restore, right?
Do we have to pass any command?
Reload restore command itself was there, not anymore there. Okay. Now the thing is, this command works when the device is reloaded. This command only works when the device is reloaded, because we may have a failure like this when the device is actually not reloaded. We may have a failure when what happened first? Your link went down. What happened to the secondary? Next, member ports go down. Then the whole device went down. The primary as the whole device went down. Then what happens? This goes down. Secondary still remains secondary. Primary, everything is down. Nothing is happening, right? But did this device reload? Did the secondary device reload? Because this command only works for what? A reloading device. After reloading, I'll wait for 300 seconds, and even if the other side does not talk to me with respect to VPC, I'll make it up. But this secondary was not reloaded, right? It was still up this time. So what they came up with was a command called this. If you go under the VPC domain and give a command 700, if you give a question mark here, you have an option something known as auto recovery. This one. So there is something known as auto recovery that has replaced the reload restore. Auto recovery works for both the scenarios. Auto recovery works if the device is reloaded. Auto recovery also works for this scenario. So now what happens is, if the primary fails, the secondary now is actively actually seeing the primary is up or there or not, and after 240 seconds approximately, if the primary has no communication with it, it will make its member ports up.
The little way how to, let's say in the data center, I have perhaps more than 3 or 4
More
than 3 or 4 with this domain. The Cisco has a specific software to monitor.
In one switch, you can only create one VPC domain.
I'm saying this for the complex data center, even to VPC, maybe I have about 4 or 5 VPC in my.
You can have from the same infrastructure like this, right? This is another VPC.
Okay. So the little way how to monitor automatically, not manually, goes the commandization.
You can run scripts on it. You can run EM scripts and all those things. Can be done.
Okay.
But you need to know about them first, right?
I would say make the software which is
yes, there are possible ways of doing that. That's the whole point of this SDN, right? Now, or ACN. So it's the whole point of ACN. They don't want the network administrators. They are becoming great to us, behaving good to us. They don't want us to wake up all night because then the software will do it. If something wrong happens, error message comes, I can run a script that telling what to do in case this error message comes or this log message comes. Right? That can be done. That can be even done with EM scripts. Now, auto recovery is a command that is not recommended to be there in your configuration. First of all, understand this. Why? Because auto recovery is not a command that should be there in your configuration. This is a command that is given for situations. This is a command of a situation. This is not a command for to be there inside your configuration. Why? Because this may happen. You have VPC going down. This is my peer link. This is my keep alive. This is my primary. This is my secondary. Right? Now, auto recovery command. If you give it by default there, right? If it's by default there, what may happen that the peer link has gone down first, secondary makes it down, right? Right? Then the primary didn't go down, say for example, then only the peer people went down. Then it's good that the secondary keeps it down. It's good that. If the primary as a whole went down, then it's not good that the secondary keeps it down. Then I'll use what? Auto recovery. But in this case, if you use auto recovery, what happens then? It's different. So this command is not a command to be there inside the configuration. It's a command of situation. Auto recovery. Okay, you don't just give it always. You just give it according to what situation you face. A command of situation. So if I now see the other failure here. So we saw this failure, right now. The failure where my peer keep alive went down first and then peer link went down. So what we saw when peer keep alive went down first, nothing happened. And then peer link went down, then there was no communication between the two devices. And it was just the link fail. It was not the device failure right here, right? So we have a problem of what? Split brain in this case. If it was a device failure, then no problem. Actually, right? If that was just a link failure, then there is a problem of split brain. Now another topology is, so let me check. I'll make it up. Okay, right now what is down? If you check show VPC, your peer link is also down, your peer keep alive is also down. When you're troubleshooting, you are in a hurry right now, right? The manager is on top of your head and you are trying to troubleshoot this problem, and you try to troubleshoot by making your peer link up first. Because my thinking is peer link is the most important thing in VPC, right? I went and make my port channel up. Nothing happens. If you first bring your peer link up, it will not come up. It has to see the peer keep alive. Okay, so if you check show VPC, did the peer link came up? Peer link is still shown as what? Down. Right? Peer keep alive is not operational, that's why. So even if you try to troubleshoot and try to bring the peer link up first, nothing happens. You have to make peer keep alive first. That's why order of operation is very important. So what you need to do first, make the peer keep alive first up, then make the peer link up. So when you do such troubleshootings, always make sure that first is always peer keep alive that you will make up. Okay, so if you check now show VPC, see now it came up. So if you bring the peer link up, nothing happens. Remember, do not make the peer link come up first. Always make the peer keep alive first and then only the peer link, because on the first class of VPC itself, I told that's the way VPC works, right? So if it comes up, everything should go back fine, and it becomes now what type of device? It was previously primary, now it became operational secondary, right? And what happens to this device? He becomes operational primary. Now they have switched over the roles, because what role matters is operational role, not the configured role. Okay, so currently he has become secondary and currently he has become primary, And if I check show VPC, the member port should also have come up fine on the secondary as well as should be fine on my primary. Okay. Now another failure scenario where what happens first? Peer link goes down first, then peer keep alive goes down. What did you do? Is let us first make the peer link go down first. How would I do that? Go to the port channel number 700, shut it down. So what happens when the peer link goes down, guys? The primary, nothing happens, right? Because right now VDC2, remember it's the primary device. Nothing happens to the primary. But what will happen to the secondary? Member ports are down. It's operational secondary. Now, after the member ports are down, then the peer keep alive failed. Okay, so I'll make the peer keep alive fail 3/26. I'll make it shut down. Show VPC. Did I do anything? I still am operational primary, right? Peer keep alive is not, but its port channel is still down, right? And did it became primary or something? Because to have that role, your peer link has to be up. To have that role of primary and secondary, how does it resolve the role? Only through the peer link. That has to be up. So it's down, it can do nothing now. And it's actually good right now because the device didn't fail. Right? Only the link failed occur and one side is still up, so the data traffic will still flow. But what if the device had failed, right? What if the device had failed? Then the secondary will never come up and never bring its ports up. Then that's like whole thing going down. And that's where you give what command? The auto recovery command. So say for example I reload, and it's good that VDC2 became the primary. Why? Then I can reload him separately. Because if VDC1 becomes primary, then what happens then? I can't reload, right? I cannot shut down this device, right? If I want to shut down the device and simulate the problem, I need to reload the device, right? Are you getting my point? So can I reload VDC1? If you reload VDC1, all the VDCs are gone. So it's good that what became primary? VDC2. Because then I can only reload that VDC and no other VDCs are affected. Are you getting my point? So to simulate problems, you exactly need to know what to do first of all. Okay, so I reload what VDC, the current VDC can be reloaded, right? But as I told, there is a command that helps us to make the secondary up, because even if you reload and say the whole device had gone down, right? Do you want to save the configuration? I say yes. Even if the whole device had gone down, does the secondary make it up? Doesn't. So at this point of time is where I go under the VPC domain 700 and give what command? Auto recovery. And by default, as you see, what is auto recovery status? Disabled by default, right? What is also disabled? Things like peer gateways are also disabled. What is enabled? Graceful consistency check, where I told in case there is a type 1 inconsistency, then only the secondary side goes down again. But here I do auto recovery, and after some amount of delay, or if you hit enter, I think it's 240 seconds by default. So it waits for 240 seconds, and after 240 seconds, if nobody communicates, then I'll bypass all the checks and then make my member ports up. Okay, this happens only after 240. That's the minimum time you can configure actually. So if you give auto recovery, reload, delay, and if you give a question mark, 240 is the minimum amount of time that can be configured. So we need to wait for how many seconds?
4 minutes. 240.
240 seconds. So it will still be down. Okay. after only 240 seconds. So till then, let us fill this. So what happened to affect on election? Peer link first went down, then peer keep alive went down. There was no effect on election, right? What happened to VPC? Since there was, because both became what? One was secondary, one was primary. So VPC was up on the primary side, right? Because this is like a second failure scenario, right? Like that, where the peer link failed. What happened? Primary was still up, secondary made it down. What happened to the SVI? The same thing happens to even SVI. What happens to the data traffic? It's actually up if the primary is up, but there is another failure where the link didn't go down, but the primary itself went down. Orphan device up, but actually it loses all the connectivity. But so for orphan device, you have to have another link. But if you make another link here in VPC, so for the orphan device, you made another link. What happens to that link? Say I had another link for the orphan device, which is a layer 2 link itself. What happens to this link? This link is always blocked by spanning tree. Because spanning tree cannot block what link? Your link. So this link will always be blocked by spanning tree. In case peer link goes down, then this link might come up. Okay. So here there is something called auto recovery command that can be used. Right, for secondary to recover in case primary as a whole goes down. See what happened. Type checks were bypass for VPC, and it became what device? Primary device. And if you check show VPC itself, I have enabled the auto recovery, which by default takes a time of 240 seconds. Do you get this, guys? Everyone clear with this?
But after that, do I need to recover other manual after bypassing all the consistent consistency?
Yeah.
I was just thinking.